Okay, this is the other sheet. This is the other page in the white packet that has examples of piecewise functions and finding limits of piecewise functions. So again, you should do this as practice. We didn't get a chance to talk about finding the limit of a piecewise function, so what I would do is watch the video as I do this first example, and then after I do the first example, I would pause the video, see if you can figure out examples 5 through 16, and then resume the video and watch and check and make sure it's making sense. So it says find the limit as x approaches 3 from the right. So again, we think of it as, okay, I have an infinite list of xy pairs. The x-coordinate I'm interested in is the x-coordinate that is just a little bit more than 3, just barely more than 3. Well, as we talked previously, we have a formula here. The formula is how we find all of these xy pairs. So I'm looking for the x that's a little more than 3. So this tells me when the x-coordinate is slightly more than 3, when the x-coordinate is slightly more than 3, that's what this is, you use this formula to find the y-coordinate. So I'm going to take 2 multiplied by an x-coordinate that is slightly more than 3 plus 1. That's going to come out to be, the precision here is not critical. 2 times 3 is 6. This is pretty close to 6. Plus 1 is going to be really close to 7. Doesn't really matter whether it's a little more or a little less. I know that it is infinitely close to 7, infinitesimally close. So this limit as x gets infinitesimally close to 3, but x is just a little bit more than 3, the y-coordinate is going to be infinitesimally close to 7. That's the answer to that right-hand limit question. Now the left-hand limit. So when x is just a little bit negative of 3, slightly less than 3, let's see here, so x is just a little bit negative of 3. That means x is just a little bit less than 3. So I have to use this formula. So I always replace variables with parentheses. So I take away the x, put it in a set of parentheses. I choose a value of 3 that is slightly negative of 3. That's going to get squared. Subtract 2. Again, you don't have to be super precise. 3 squared would be exactly 9. So that's pretty close to 9. Subtract 2, it's not going to equal, but it's going to get close. 9 subtract 2 is going to be really close to 7. So when the x-coordinate is just infinitesimally less than 3, the y-coordinate over here is going to be infinitesimally close to equaling 7. To answer this question, I do not look at this at all. I do not look up here. I only look at the results of the left and the right. Because they're both 7, this is 7. I don't do any computations, I just do a comparison. F of 3 is different, however, because now x has a value that is exactly 3. So when x is exactly 3, y is exactly 2. And for future reference, because the left and right limits are the same, there's not a jump. Jumps only occur in piecewise. There could have been a jump. But because the left and right limits, oops, did that wrong. The left limit and the right limit are the same, so there's no jump. But because the overall limit does not match the value of the function, this one does have a removable discontinuity at x equal 2. They didn't ask you to write that, but you'll need that for some future things. So with a graph, you can see the discontinuities. Right here at x equals 0, there is a removable discontinuity. You can see it. At x equal 2, there's a removable discontinuity. You can see it. However, at x equal -2, x equal -2, that's a jump because the left and right limits won't be the same. Over here, clear this off. Right here, that's a removal, that's a jump, sorry. X equals 0, that's a jump because the left and right limits are different. X equal 2, also a jump because the left and right limits are different. X equal 3, the left and right limits are the same, but the value of the function is different, so that's a removable discontinuity. So with the graph, you can see the discontinuities. With piecewise, you have to do some computations to check and see what's happening. So I would pause the video now. I would try to work through 5 through 8, start the video again, check your answers, proceed in that manner to make sure you're figuring it out first, and then just using the video to check your work. Okay, so limit as x approaches 1 from the right. So x is an infinitesimal amount greater than 1. So x is just a little bit greater than 1. So I'm going to use this formula. So when x is slightly bigger than 1, I take 3 multiplied by that x plus 1. Don't need to be super precise, but this is not going to equal exactly. 3 times 1 is 3, plus 1, so that's going to get really close to 4. So when x is infinitesimally greater than 1, the y-coordinate is getting infinitesimally close to equaling 4. 1 minus, that's the left-hand limit. So now x is slightly less than 1. So I have to use this formula. So when x is slightly less than 1, I have 2 multiplied, oops, not messed up there, hold on. That. So 1 less, minus 1. So 2 times 1 is 2, so this is going to be really close to 2. Subtract 1 is going to be really close to 1. So this limit is 1. Because the left limit did not match the right limit, this limit is non-existent. Again, to find the overall limit, I did not look at the formulas. I only looked at what happened on 6 and 5. I compare the right-hand limit and I compare the left-hand limit. G of 1 means I plug in exactly 1. So up here, when x is exactly 1, using this formula, 2 times 1, subtract 1, that's going to be exactly 1. The left and right limits do not match. Therefore, the overall limit is non-existent. That's a jump because the left and right limits did not match. Okay. As x approaches 3 from the right, so x is a little bit more than 3. X is a little bit more than 3. So x is a little more than 3. So I have to use this formula. Again, when I remove the x, I'm going to put parentheses. You should always do that. So a little bit more than 3. 2 times 3 is 6. Plus 4, that's going to be really close to 10. So if the x-coordinate is just infinitesimal amount greater than 3, the y-coordinate will be infinitesimally close to 10. Remember, the answer to your limit question won't ever have the plus or minus. 3 negative, that's the left-hand limit. So when x is just infinitesimally negative of 3, just a little bit less than 3. So I have to use this formula now. So when x is just slightly negative of 3, remember, remove the x, put in parentheses. So 3 squared would be 9. 9 minus 4 would be really close to 5. So when the x value is just an infinitesimal amount less than 3, the y-coordinate's getting infinitesimally close to equaling 5. Once again, to answer the overall limit, I do not look at the formula. Instead, I look at the right-hand limit and the left-hand limit. Because they do not match, this limit does not exist. H of 3 is 7. When the input is exactly 3, the x-coordinate is exactly 3, the output is exactly 7. This is a jump again because the left and right limits did not match. Okay, last one here. Okay, so we have the limit as x approaches -2 from the positive side. So that means we are slightly greater than -2. So x is slightly greater than -2. So we use this formula. X is slightly greater than -2. I replace the x with parentheses. Should always do that. It won't be exact, but it's infinitesimally close. -2 plus 5 is infinitesimally close to 3. So when x is infinitesimally just a little greater than -2, y-coordinate is going to be infinitesimally close to 3. Therefore, the value of the limit is 3. When x is infinitesimally negative of 2, means x is just barely less than 2. Use this formula. So x, y here. X is just a barely negative of -2. Place with parentheses. -2 squared would be exactly 4. -2 squared is exactly 4. -1 would be 3. So this is infinitesimally close to being 3. So this limit is exactly 3. The right limit matches the left limit. Therefore, the overall limit is also 3. Notice once again, I answered this question not by going back to the formula up here, but by checking the right-hand limit and the left-hand limit. Because they are the same, the overall limit is also 3. K of -2 is different. That means we're supposed to go figure out when the x-coordinate is exactly 2. Well, this formula tells me what to do when x is less than 2. This formula tells me what to do when x is greater than 2. There's nothing in the formula telling me what to do when x is -2, so the formula is undefined. The formula doesn't tell me what's happening. Left and right limits match. but the overall limit does not match the value at x equal 2. Therefore, this is a removable discontinuity.